Now we come to the session 14. We already know in the session 13 the basic definitions regarding the convergence of power series. Now in the sessions 14, so we know I recall the basic definitions. I am going to prove as some theorems on circles of convergence. Now we draw a circle of radius r with the center at the origin. Then first one, the power series summation an z power n is convergence for z within this circle mod z less than r. Second one, the power series summation an z power n is divergence for every outside the circle mod z greater than r. Such a circle is called a circle of convergence and its radius r is called radius of convergence of the power series summation an z power n. Sorry. There are three possibilities for r. We already know in the previous sessions for r equal to 0. In this case, the series is convergence only when z equal to 0. Second one, r is finite. In this case, the series is convergence at every point within this circle and is divergence at every point outside the circle. Right. Outside the circle. Third one, if r is infinite, in this case, the series is convergence for all z. R is infinite. In this case, the series is convergence for all z. For if we take a remark, suppose if we take 1 by r is equal to limit n tends to infinity, absolute values of n whole power 1 by n means root test you are applying here. 1 by r is equal to limit n tends to infinity, absolute values of n whole power 1 by n is equal to limit n tends to infinity, absolute values of an plus 1 divided by an. So we are applying a root test is a ratio test. This follow from the Cauchy theorem on limits. So you are applying you are comparing this. This is possible if r is 0, the series is convergence and z equal to 0. So yeah, if r is finite, the convergence within the circle or divergence outside the circle. If r is infinite, in this case, series convergence for all z. So the same way I am going to prove some problems and theorems here. Investigate the behavior of summation zn divided by n on the circle of convergence. Suppose if we take a is equal to 1 by n, then 1 by r is equal to limit n tends to infinity, absolute values of n whole power 1 by n is equal to limit n tends to infinity 1 by n whole power 1 by n. So again, limit n tends to infinity 1 divided by n to the power of 1 by n. So we know the standard limit n tends to infinity 1 by n to limit n tends to infinity 1 n to the power of 1 by n is equal to 1. If a limit n tends to infinity, by using this limit n tends to infinity, 1 divided by n raised to 1 by n is equal to 1. So suddenly, if r is equal to 1 or finite, evidently the center of circle of convergence is at z equal to 0. So center of circle convergence is at z equal to 0. And radius r equal to 1 at that point z equal to 1 on the circle of convergence, the given series becomes summation 1 by n, which is a divergence series. You know the sequence and series form, summation 1 by n is a divergence series. To examine the behavior of the power series for every values of z on the circle convergence except at z equal to 1. This is theta. To examine the behavior of power series for every values of z on the circle convergence except at z equal to 1. Now let summation z power n divided by n is equal to summation an un. When we take an is equal to z power n and un is equal to 1 by n. So we shall make use of a Dirichlet test. The following conditions are satisfied. So we are if we apply here the Dirichlet condition. So Dirichlet condition. So what does it say? So sum of the term we denote Sn, absolute values of Sn, absolute value. Summation R run from 1 to in, R run from 1 to n. This is absolute should be equal to absolute values of z plus z square plus etc. z power n. So again, this series can be written as absolute values of z into 1 minus z power n divided by 1 minus z. Again, we can write open this z minus z power n plus 1 divided by 1 minus z. Suddenly, this is suddenly less than or equal to absolute values of z plus z power n plus 1 divided by absolute values of 1 minus z. So again, if we limit n tends to infinity, suddenly we get 1 plus 1 divided by absolute values of 1 minus z. Suddenly 1 plus 1 is 2 divided by absolute values of 1 minus z. So suddenly sum of Sn suddenly less than or equal to 2 divided by 1 minus z. So this proves that sequence Sn is a partial sum is bounded, because we get the values and the right hand side, suddenly this number is less than 2 divided by absolute values of 1 minus z. Suddenly this number is something constant less than this. So this proves that the sequence Sn is partial sum is bounded. It's a partial sum is bounded. Now we take one more example. Take a limit un is equal to limit n tends to infinity 1 by n. So is 0. Second one, the consecutive term means un minus un plus 1 is equal to 1 minus 1 by n plus 1. So I take LCM 1 divided by n into n plus 1. Suddenly this number suddenly less than 1 by n square. So we know this un minus un plus 1 less than or 1 by n square. Also the series summation 1 by n square is convergent. Therefore, the summation un minus un plus 1 is convergent. Hence, the series summation un is equal to summation z power n divided by n is convergent for every values of z other than 1 on the circle of the convergence. So, here we observe by using this theorem. So investigate the behavior of z power n by n of the circle of convergence. Here 1 by r, if we apply the root test and the ratio test in the recovery. So if we are applying the root test, limit n tends to 1 by n whole power n. So limit n tends to infinity 1 divided by n. So you are getting. So here finite return suddenly is a series is convergence. Circle is convergent at z equal to 0. Is divergence, we know that series 1 by summation 1 by n is divergent. So this is the behavior like this. If one convergence, certainly convergence the other types. So if we come to this, we come to the one more example here. The same example we are taking z power n, examining the behavior of the power series. Summation n tends to 2 to infinity z power n divided by n into log n whole square. So on the circle of convergence. So to take examples, behavior of the power series summation n run from 2 to infinity z power n divided by n times of log n whole square on the circle of convergence. I call this series summation an equal to I call the series an is equal to 1 divided by n into log n whole square. So apply the ratio test, an plus 1 divided by an. So n applying n log n whole square divided by n plus 1 into log of n plus 1 whole square. So I am simplifying, sometimes get cancelled, simply we get n log n whole square divided by n plus 1 into log of n plus 1 whole square. Again, I am dividing. This should be equal to 1 divided by 1 plus 1 by n of log of n into 1 plus 1 by n divided by log n whole square. Log n whole square. Again, this equal to, I take this, instead of this, I taking denominator of denominator. Denominator of denominator. We get 1 divided by 1 plus 1 by n of 1 plus log of 1 plus 1 by n divided by log n of whole square. This equal to, so it is equal to 1 divided by 1 plus 1 by n of 1 divided by 1 plus 1 by n log n minus 1 divided by 2n square log n plus etc. Here you apply it in the formula. You are applying the formula. So here 1 divided by 1 plus 1 by n of 1 plus log of 1 plus 1 by n divided by log n whole square. Again 1 equal to 1 divided by 1 plus 1 by n of 1 divided by 1 plus, we are applying the formula 1 plus 1 by n log n minus 1 by 2n square log n plus etc. whole square. This equal to 1 by r is equal to limit n tends to infinity, the ratio an plus 1 divided by an is equal to 1 by 1 into 1. So if we apply the limit, the product we will get is 1. So we get 1 by 1 into 1 is equal to 1. So suddenly 1 by r is equal to 1. Suddenly r is equal to 1. The radius of a circle of a convergence is 1 and the center at z equal to 0. So your radius of a circle of a convergence is at 1. So this is a finite number. If r is 1, it's a finite. The circle of radius of circle is convergence 1 and the center at 0 for every point on the circle is convergence. So absolute values of Zn divided by n log n whole square is equal to 1 by n log n whole square. So it's fine. For margin equal to 1 on the circle, also summation 1 divided by n log n whole square. Summation 1 by n log n whole square is convergent by Cauchy comparison or by Cauchy conditions test. Hence, summation Zn divided by n log n whole square is absolutely convergent for all z on the circle of convergence. So here this is the type of a difficult problem I am going to explain here. So we know the basic conditions of a log of n log n of 1 plus 1 by n divided by n formula. So we apply this series of binomial expansion formula. Suddenly we get, if we take a limit n tends to infinity, this binomial expansion should be is omit n 1 divided by n log n minus 1 by n square 1 by n. This is omitted. Only we get 1. So if you apply this is equal to 1 by 1 into 1 should be 1. This is omitted. Of this 1 plus something is, if we n tends to infinity, this is 0. So suddenly we get is 1. So 1 by 1 into 1 equal to 1. So radius of circle of a convergence is 1 and the center at z equal to 0. For every point of the circle is convergent. So that is the absolute values of z power n divided by n log n whole square is equal to 1 divided by n log n whole square for r equal to r margin equal to 1 on the circle, means margin on the circle. So this is the value summation Zn divided by n log n whole square is absolutely convergence for all z on the circle of the convergence. So circle of the convergence. So we come to the same problem regarding we take that the examine the behavior of the power series summation z power 4n divided by 1 plus 4n. So n run from 0 to infinity. So the same examine the behavior of the power series summation n run from 0 to infinity z power 4n divided by 1 plus 4n on the circle of the convergence. Now here take an is equal to 1 divided by 1 plus 4n. And let 1 by r is equal to limit n tends to infinity an whole power 1 by n. So limit n tends to infinity, is an plus 1 divided by an is equal to limit n tends to infinity. If you apply this, we get, if you apply, so 4n plus 1 divided by 4n plus 5. So if you apply this limit, replace am in now, replace n by n plus 1. Yeah. So here an we will take 1 divided by 1 plus 4n. So if you take a limit n tends to infinity an plus 1 divided by an, we get replace 1 divided by 1 plus 4 of n plus 1 divided by 1 divided by 1 plus 4n. So we get 1 divided by 1 plus 4n plus 1 4 all divided 1 plus 4n divided by 1. So we get 1 plus 4n divided by 4n plus 5. Yes, this is 4n plus 1 divided by 4n plus 5. Again, I take 4n as a common. Limit n tends to infinity. 4n I will take common. We get 1 plus 1 by 4n. Again, 1 divided by 5 by 4n. So if you apply the limit, this term will get cancelled. 4n get cancelled. Suddenly, if you apply the limit, 1 divided by 1. So suddenly 1. So r is equal to 1. Hence, the radius of a circle of a convergence is 1 and it is centered at z equal to 0. At z equal to plus or minus 1 or plus or minus I. Means z equal to plus or 1 or plus or minus I. The given series become summation 1 by 1 4n plus 1. Summation 1 by 4n plus 1, which is a divergence since it is of the form 1 by 4n. It is of the form 1 by n. So this is which is a divergence since it is of the form summation 1 by n. Hence the given series is not convergent at z equal to plus or minus 1 plus or minus I and its circle of convergence. So suddenly is of a form 1 by n. 1 by n is divergence. Product of 1 by 4 times of n. This is also a divergence. So this is of the form is on the circle of to examine the series at which at every other point on the circle of convergence we apply the Dirichlet test by comparing summation z power 4n divided by 1 plus 4n by applying the Dirichlet conditions. So summation z power 4n divided by 1 plus 4n with summation an un we get. So an we take an is equal to z power 4n and un is equal to 1 divided by 1 plus 4n. So if we take the series an is equal to z power 4n and un is equal to 1 divided by 1 plus 4n. So we get, so if we take sum of the Sn is equal to absolute value summation ar run from 0 to n minus 1 times. R run from 0 to n minus 1 time ar is equal to absolute values of 1 plus z square, z raised to 4 plus z raised to 8 plus etc. plus z power 4 times of n minus 1 is absolute value. That is, we get absolute values of 1 minus z power 4 whole power n, z power 4 whole power n divided by 1 minus z power 4. So again, should be less than or equal to 1 plus z mod z whole power 4n divided by 1 minus z power 4. So this should be equal to 1. If you apply the limit n tends to infinity, suddenly we get the numerator 1 plus 1 divided by absolute values of 1 minus z power 4. So is 2 divided by 1 minus z power 4. So if you apply it, suddenly this is less than or equal to some constant. So suddenly 2 divided by absolute values of 1 minus z power 4. So for mod z equal to 1 on the circle of a convergence, so sum of the series suddenly absolute values of Sn less than or equal to 2 divided by absolute values of 1 minus z power 4 is something is a bounded form. This is a bounded means consequently the sequence Sn is partial sum is bounded. So this is that some constant suddenly less than or equal to some constant. Consequently sequence Sn is a partial sum is bounded. Similarly, we apply the consecutive term. The absolute values of un minus un plus 1, if we take, suddenly we get 1 by 4n plus 1 minus 1 by 4n plus 5. So, simplify, I'm taking LCM and cross multiply, suddenly we get 4, if we take 1 divided by 4n plus 1 minus 1 divided by 4n plus 5 is equal to, we get simplify and cross multiply, we get taking LCM and cross multiply. So 4 divided by 4n plus 1 into 4n plus 5, suddenly this number, if you take 4 as common, we get 4 as taken, 4 get cancelled, 4n square we get here, one term get cancelled, suddenly n square we left, 1 suddenly 1 divided by 4n square, suddenly less than or equal by. So 1 by n square is convergent. So I write un minus un plus 1 suddenly less than 1 by 4n square. Also summation 1 by n square is convergent. If you multiply 4 times of 1 by n square is also convergent. So therefore summation un minus un plus 1 is convergent. So this is the series is convergent by using comparison. So limit n tends to infinity un is equal to limit n tends to infinity 1 divided by 4n plus 1 is 0. Limit n tends to infinity un is equal to limit n tends to infinity 1 by 4n plus 1 is 0. The above factor prove that the summation an is equal to z power 4n divided by 1 plus 4n. Summation z power 4n divided by 1 plus 4n is convergence for all z on the circle of the convergence except z equal to plus or minus 1 or plus or minus I. This is follow the Dirichlet test. So above the fact that this is the term is convergence for all z except at z equal to plus or minus 1 or plus or minus I by using the Dirichlet test.